This is Miao speaking here. So today we will go through the Superfluid framework, and the format would be we'll go through the tutorial actually written very quickly by Patrick. Kudos to that, Patrick from this chat. And I'll go through the tutorial that Patrick wrote and regarding two building blocks, and I'll give an overview of what are they. And in the end, we'll show you a surprise demo also. We just hacked up today. Hopefully it will be interesting. But first, I will let Francesco give a very brief intro about the Superfluid Finance in the first place. Yeah.
Hi guys, nice to see everyone. A lot of familiar faces and also a lot of new faces, which is great. So Superfluid is a suite of smart contracts which will be deployed on Ethereum mainnet and maybe, who knows, on XDAI and Matic network and other chains, who knows. For now, it's on goerli testnet. So the contracts are deployed. I'm currently building a dApp, which hopefully in a few minutes we'll be able to share with you guys. So at the moment, as I said, it's on goerli, but most of the functionality is already built. We're hoping later this month, hopefully by ETH Online, we'll be able to deploy mainnet, so everything will be live and working. So Superfluid essentially is a new token standard which builds into the token new functionalities which try and go beyond the simple ERC20 standard. So some of the functionalities are the flow agreement, which is how we call money streaming. So if you've heard us talk about money streaming, technically we call it a constant flow agreement. So it's an agreement, and our framework can actually support any agreement if it's built with specific constraints. So at the moment we have the constant flow agreement and we have the instant distribution agreement. And these are both built into the token, which means any token deployed through Superfluid or wrapped into Superfluid can use these functionalities. So the constant flow agreement, which is what our demo is going to be about, is a stream of money. So how it works is it goes from the account of Bob to the account of Alice as soon as the transaction is minted on the blockchain. All that needs to be specified is the quantity per second to be transferred. And after this, the money starts flowing. So the balance increases automatically. This is done in a similar fashion as to how ADAI increases balances with interest. Only here it's programmatic, so you can increase it just by opening or closing flows. So I think I'll leave it to Miao to maybe start showing something off. There is a lot more to Superfluid than just a token standard. There are other functionalities, but I'll leave it to Miao because he's much better than me at explaining the technicals.
Right, thanks. To start with, I would first recommend you to go to this repository, Superfluid-Finance on GitHub /Superfluid Protocol-preview. And just a quick note that our contracts are deployed to goerli at the moment, and the core logic currently are not published in this repository, but it doesn't stop you actually to deploy the contract because the truffle contract artifacts are all published here, while the sources are stripped, some of them, to protect us from some spam at the moment. But we'll be publishing the full code fairly soon. And there also a disclaimer, so the contract is still under a little bit development. So if you found any bugs, don't be surprised, just let us know, and we'll try to fix it before we go to the auditing. So with this repository, and the next resource you would need is the docs.superfluid.finance. This is where the Patrick created the tutorials very nicely, and we'll go through live today here. So, okay, so we will go with two tutorials, then we will go check the surprise demo later. So let's go with the create a flow first. constant flow agreement, as Francesco already introduced, it is a way for you to send from one stream, from you to anyone measured per second, and you don't need to have upfront the liquidity. So if you say like you send 100 DAI per month, you only need a very minimal amount. Technically, you only need 1 hour of liquidity. It's a configurable parameter in the system, will be governed by the governance. So if it's 100 per month, that means around 15 cents, I believe, 15 cents per, so if you, as long as your account has 15 cents, at least, then the stream will keep on going. And it's also scalable. So if you are sending, let's say 1,000 streams in your account, it doesn't matter. The system can still handle it. So all the streams are aggregated in that sense. So, but if your account balance goes to negative, anyone can actually come and liquidate your agreement, meaning that they'll stop your stream. This is actually done by our team member in the chat, I believe. Nuno, your name is X probably here? Yeah, Nuno is our developer that doing the agent which liquidates the agreement. Yeah, so basically that's a brief overview of how it works. If you have any questions, just interrupt. Otherwise, I will just go through the flow. All right, let me go to a clean environment.
Now, is the liquidation just sort of a like preserving the system thing? It's not something where you make money off of liquidating because they've got a negative balance, so there's nothing to sort of capture there, right?
Yeah, so the liquidation actually needs to be incentivized. We don't want to be the only one that does liquidation in the long run. So we want to incentivize in a way that first you can get gas fee refunded as a liquidation agent. Secondly, as I said, there is a small amount of deposit when you created a stream, like 1 hour of deposit. So that deposit would be given to the liquidator if you don't close the stream yourself, right? So if you close your stream yourself, then you get back the deposit. So for 100 DAI per month, it's around 15 cents of a deposit. But if you don't close yourself and if your account goes to almost negative, then deposit is taken away by the agent. And we have other mechanism, namely the gas token. We're still trying to figure out the details, but in general, we want to incentivize the liquidator to do the job for us and take the deposit as extra incentive.
Thanks.
All right. All right, so let's go. It's the first time I do this actually Codeup, so hopefully I'm doing it correctly. So let's see. First, clone the repository. All right. So Ethereum contracts is the one that we will run the demos. Once you are in it, I will do npm CI, but you can do also yarn install. It's the same, more or less.
Yarn is better.
For some of the build scripts, you also would need the JQ utility. If you are using Ubuntu, use apd get install. If you use some other system, I don't know, actually, I think Mac has also, but Nuno is using Mac. Can anyone tell me if you have JQ utility on your machine? If you don't, what system is it? JQ is a command line JSON processor, so some of the build scripts actually using it. So, all right. If everything is fine for you, then let's install the global truffle. If you don't have global truffle, install it. In fact, you can also use npx truffle. I believe it's also available here. Next is that you need the goerli ETH and set up environment for the goerli ETH mnemonics. So make sure that your account is funded. I'll give us.
Send me the address.
Yes, I'll send the address to the chat, and Francesco will do in the background send you some goerli ETH if you don't have if you happen to not have any. Then set up the env file with the goerli mnemonic and the provider URL. I will not show my mnemonic here, so I'll pull the screen down a little bit. I'll give probably 1 minute for you to set up. All right, now it's up. Okay, so if anyone have trouble, pin it in the chat or raise hand. There's raise hand feature, right? Zoom. No, there's no. If everything's fine, I'm gonna continue. So we will from now on we'll use a truffle console feature to try out our SDK. To do that, you type npx truffle -- network goerli console. If you have your mnemonic and provider URL set up correctly, then it should go on without error. Just to double check your accounts, web3.eth, balance off, accounts 0. Of course, it's not balance off, it's get balance. Yes, excellent. Right, apparently there are people that need some ETH, so. All right, let's slow down a bit. Let's set some utility up. Create some alias, Bob, Alice, and Dan. Once you have the alias created, you could include the SDK with the required local directory. The whole package is including the contracts and a JS SDK. What I mean is if you look at the package JSON, the main should be JS SDK index.js. That's how the entry point is.
Hey, Mia.
Yes.
Would it be possible to make your console a little bit larger, like the font?
Good point. Better?
Yeah.
All right. Okay. Thanks. Now you need, once you have the SDK, now you need to initialize, create the framework object. I'll go over what's the parameter here quickly. The version specify which version of the contract is. We are using the preview version, which is the one that we released to the goerli network publicly at the moment. And you also need to specify where is your Web3 provider. Once that's done, you have the object. Once you have the object, do the await initialize. If you have the error when you do initialize, ping here or do it again, because I have noticed recently that the chain ID returned by Web3 in goerli network sometimes give me random one. I don't know why actually. If anyone happen to know, it would be great to share why. The other hack would be hard-coded the chain ID. Then it will not try to query from the Web3. This is also equivalent. All right, so what it does is that it will find a bunch of contracts from our resolver, whereas the main contract, which is Superfluid, and 2 agreements. Once that's initialized, then we are ready to go. Should I wait? Anyone wants to a bit more time? All right. Next, let's get the test token address, which we could use the resolver to get to the F die, which is our test token. F stands for fake die, right? So once that's done, we can get to the die address and then the die token. This is a test token contract, which you can mint how you want for testing purpose. Once you have that, let's get some mint for Bob. The mint interface is quite straightforward. You specify who is one you want to mint and how much you want to mint. We're using Web3 utility to convert the to 100 18 decimal units. Just a note, since we're here, so this this is a DAI token, but a super token, the wrapper, will come soon. We all use 18 decimal, so we don't have other decimals. So you're always dealing with 18 decimal, just a note. Now let's check the balance of Bob.
I think you need to load the libraries from.
Right, yeah, I'm going back and forth. So load the test library. Oh.
No, you did it right the first time, I think. You
Okay.
just did it twice, 2 times in a row.
Okay, awesome. Okay, let's just check. Okay, now I have 300. Oh, apparently I had some other test going on. So if you just did it now, you should see 100 from this balance of query. Okay, the next step would be upgrade our test die to the super die. To do that, let's get the super die wrapper first. So super token works in a way. So in order to use any agreements we're talking about here, you need to have upgrade your token to super token. Right. So in order to get a super token, you get to the sf.contracts.isupertoken. Add the wrapper address. The wrapper address you get from the framework, get ERC20 wrapper. Once that's done, as usual, the most painful part is do the approval. Let's just approve the super token to be able to upgrade your normal DAI token. Once that's done, do the upgrade. Here I'm upgrading 50 F die to the die X. We call it super die X in symbol. X suffix is meaning the super tokens for now. All right, once the upgrade is done, do a sanity check. Your die-X balance should be, in your case, should be 50 because I had some other stream going. That's why the balance is different. As you can see, my balance is dynamic, happen to be because of how the framework works. Each time you query, if you have ongoing flow or something, the balance actually changes for each block. All right, now we can create a flow. To do things slightly different, I'm not gonna create a flow to my own account. I'm gonna create flow to somebody else who already sent the address in the chat. I'm gonna send to Victor. Victor, you're the lucky one. I'm gonna send you. Victor. This particular command will look a little bit intimidating. We're planning to wrap everything under the framework object so that you don't need to write this humongous way of sending a transaction. But just go over briefly, it's actually quite easy to read. So in order to create any transaction to the system, you have to go through the host contract. The host contract will call the eventually which one are you calling. In this case, you are calling the agreement. So we're calling the agreements.cfa. CFA stands for constant flow agreement. Right, so we're calling the agreement and with the parameter of sending die-X. We're sending to Victor, and this is flow rate per second. Let's just do a conversion in JavaScript. I believe this one is. Wait, if I multiply spaces, 24, 30 days, and I'm converting this flow rate to per hour, per 24 hours, per 30 days, and I divide by 118. So that should be 1,000 per month flow rate, roughly. Okay, that's why this number. And this is some magical stuff that I'm not gonna explain here, but
yeah, this might be a little bit advanced, but is it possible to set a automatic stop time, or do you have to always separately fire a transaction to stop it?
Currently, we cannot set a automatic stopping stream, but I believe there can be other way of doing instead of using our framework. I think there's Francesca, can you remind me which one is the one that can do the own change, trigger the actions or when there's something happening. Gelato, exactly. So yeah, but just by the low level of agreement, the CFA, it doesn't. It's an open-ended stream. Let's put it this way. It will stop when you run out of balance in your account, of course. Okay, so I'm gonna copy paste on this here. Then Victor should receive the stream. So once this is done, can you tell us if your balance?
Can you add the die-X address? I don't know if I saw that in the tutorial page. Like, what is the actual contract address for die-X?
Oh, so tutorial here said die-X equal to the super token. If you went through this, the die-X is the super token object, and die-X address would be the address of that token.
Unfortunately, I didn't make it through that part. I ran into a weird bug when I was installing. So,
okay, it's fine. So who has up and running, and you can send me the address, send it to the chat the address so that I can send you a stream also. Okay, so if let's check the front Victor's balance. I'll check it for you, Victor. So Victor already started to receive the balances. If I query the balance, receive the stream. Yeah. The other interesting function would be get net flow. So you can see what's your net flow of like your own account, for example. So CFA.get net flow, Bob, you can see that net flow, I'm net negative because I'm sending out a lot of streams. If I check Victor, it should be positive. Yes, I'm actually sending quite many. Oh, I actually also received some streams. That's why it's not so negative. Yeah, that's it. That's how it's how to create the flow. And next is how to delete the flow. It's fairly simple also. You call the agreement, you call the CFA address, and then you say delete flow, and then you say which pair you want to delete. In this case, we want to delete Bob to Victor. So if we get the net flow of Victor now, should be 0. And if I check my net flow, yeah, also changed. So Andrew asking a question, how can we extend agreements to make our own? So just quick notes on the agreements. The agreement is very intricate component of the entire framework. That's why it's not fully permissionless. So it will be more like we'll add very carefully because each agreement would be able to co-manage the balances with other agreements, right? So if one agreement has bug, then the whole account would be in trouble. That's why we add the agreement very carefully. Currently in our system, we have 2 agreements. I think the time is a little bit constrained. Correct me if I'm wrong. We have 20 minutes more.
Sorry, did you ask a question?
Yeah, so is it that we have 20 minutes more?
Yep.
Okay, so I'll go a little bit faster. So to answer the question regarding agreements, we will, currently we have constant flow agreement and the instant distribution agreement. Probably we will not have time to go over step by step. I will just go over real quick, just not executing here, but go through quickly, just reading over. And the third agreement we're going to create fairly soon is called flow distribution. It's like flow, but also instant distribution. So it's a hybrid of both. So-called instant distribution is that it's a way that you can distribute token to, let's say, 1,000, 2,000, or 1,000,000, doesn't matter. It will just be one transaction, and everyone who is approving that subscription could receive the instant distribution in one transaction. So let's say you could distribute 1,000,000 DAI to 1,000 address in one transaction. Actually quite effective, quite efficient. Yeah, I can just run through quickly. It shouldn't be that difficult. I'm gonna just do that. I have some address already in the chat. I will do that distributions. All right. So first thing I need to do is create an index. Andrew, I'll answer your question, the other one a little later.
Sure.
So this one is that I'll create a index. Think of it as a pub sub. So it's like I'm creating publication here. Right, from Bob, I'm creating IDA. IDA means Instant Distribution Agreement. In this case, we want to create an index for the DIEX token, and index ID is 42, or you can put whatever. Forget about the 0x, and it will be sending from Bob. Right, once I have that index, I can then update subscription for, okay, I'm gonna use some, I see two edges, and one's Miguel, and the other one, I don't know how to pronounce your name, sorry. I'll set Miguel here.
I'm sure, yeah. I don't have all my environment working yet.
Okay. Maybe I just use my own account. It's easier. What I'm gonna do next is let one of my account approve the subscription. So in this case, I wanted Alice to approve the subscription from Bob. So Bob now can update, can send, can distribute the rewards to Alice in this case. So let me approve. So next would be, actually here is a very good diagram. So Bob would be the publisher, and Alice and Dan would be the subscriber, right? Okay. Now we need to give Alice 20 units of subscriptions. Think of it as shares, okay? 200 shares of Tesla share, or 200 of shares of something else. You know, we give Alice 200, and then we can distribute from Bob's account. All right. Now let's do the magic here. Distribute. Data utils to way. Distribute 10 and okay, that's the case. What's going on? Distributing is 3. All right, that's interesting. Oh, I need to specify the index ID, of course. Index is 42. And I'm in this case, I'm distributing 10 DAI from Bob's account to subscribers. We only have 1 subscriber, so this one probably not so interesting. Wait a minute, I'm gonna do another update units. Let's give Dan, according to the diagram here, that should be 100 units. So in this case, Dan would have 100 shares and Alice have 200 shares. So if Bob's sending 10 DAI, we should expect that Dan receive 3.3 and Alice would receive 6.66. Let's hope that's the case. Let's transaction down. Okay, let's distribute. So if we check the Alice balance, how do we check the balance? X balance of Alice. All right, so Alice had some balance already before. Dan currently doesn't have balance because it didn't subscribe, but if Dan approve the subscription, you will see the balance immediately. Approve subscription, let's then subscribe to it. So I went a little bit back and forth with this one, but I recommend you to have a deep look into the distribution agreement. And if I come to Dan's, yeah, 3.3, yeah, exactly. So Alice had a little bit more because of the stream that it was receiving from some other accounts. I believe I was doing some testing, but otherwise Alice basically just got distributed 6.666 from Bob. And this is scalable also. Bob literally can distribute to unlimited amount of accounts in one transaction, and as long as the account approved it, they can see the balance immediately. If they don't approve it, they can still claim it. What I mean is that agreements.ida has a claim function, so you can claim the balance with one transaction. But if you pre-approved it, then you can see the balance in real time, meaning that when Bob distributes, you will see the balance immediately without going to do a claim. The caveat is that you can only approve up to 256 subscriptions because of technical limitation, but otherwise you won't ever lose a token. As long as you approve, you can see it. If you don't approve, you can claim it, as simple as that. So you can read through this technical documentation about more about the instant distribution. We don't have much time, 10 minutes. We want to show you a very cool demo. No? But I'm gonna, one moment. I'm gonna show you a real interesting demo here. Is there any question? Can anyone?
I have one for you. Yeah. Why does a user have to approve to see the balance?
Yeah, Frank.
That feels superfluous on my end, but obviously I'm underinformed.
Andrew, so basically, as Meow said, there's only 256 slots for receiving instant distribution agreements. So the problem is, if you don't have to approve one of those slots, somebody else could technically spam your account. That makes sense?
Yeah, I get it. But so you can, more than 256 people would receive, but through the IDA, someone, person 257 has to submit a claim. They can't necessarily subscribe.
No. Sorry, that's failure on my side. Each user can receive from 256 different distributors. One distributor can go to any number of users. There's no limit. Mm-hmm. So if you're receiving dividends from 257 different dividend payers, then you have to use 2 accounts, if that makes sense.
Okay, I see.
Yeah,
I see.
I mean, it's a fairly big number.
No, yeah,
but it could be spammed.
Yeah, I got you though. So it's not a limitation on distributions. It's just like the incoming WebSockets I'm allowed to support is 256 to 1 port type of deal.
Yeah, kind of, exactly. So a user basically only has 256 inbound ports. So yeah, if you can spam them, then you can spam them. So in order to avoid that, you need to approve. What's that?
What's the actual technical limitation there?
Yeah, I will answer that. So the reason there is a 256 limitation is that because in order to receive those dividends, you have to literally query those indexes, right? We call it index here. You have to go through the indexes each time you go through the index, you have to read one storage. And we use a bitmap to be able to find the indexes. And we happen to only use one word, which is 256. That's why we have 256 maximum. We could actually extend to 2x, right? With 2 words, you can have more, but we would decide just one word, just to save some gas. But otherwise, that's where the limitation comes from, because each time you want to add a balance from some accounts, you have to read where's the balance come from. But from publisher point of view, there's no limitation, because you are just updating a number, and then everyone's balance gets reflected. Does that make sense?
Yep, gotcha.
All
Thanks.
right. Okay, so we're going to show you some magic here. I'm not. So we don't have the. Okay, it's fine. I'm going to run this over a ngrok. Before that, I need to change a little bit here. I just deployed the app. Francesco, do you have time to describe what's app when I'm setting up here?
Yeah, sure. So mute yourself. So an app is basically the way we are able to integrate the constant flow agreement into a smart contract. So obviously you can just write a smart contract that opens a constant flow agreement. However, there is no native way, if you don't use an app, to realize when a flow is closed. So if you only help users to open a flow, then users will open a flow, and then 2 blocks later they can close it, right? So in order to accurately build an application which uses flows, we need to be able to trigger our smart contract both when it's opened and when it's closed. So an app is basically a smart contract which has registered with the Superfluid host, saying that it will use certain callbacks. And those callbacks are called automatically when a stream is closed. So for example, the lottery app, which Meow is loading at the moment. So I'll just describe briefly how it works. So we have any number of users, and they can open a stream towards our smart contract, which is a super app. This smart contract takes all the incoming flows and gives them to one winner. So at any point in time, the smart contract has 0 balance, because all the incoming money is being sent out to the winner. Every time a new user joins or one of the existing users leaves, then a new winner is selected and receives that total flow. So does that make sense? So this, as I was saying, this would only work if we check for users leaving, because if we didn't check for users leaving, we wouldn't have the accurate information in the smart contract. So I hope that describes a bit what a super app is. Does that make sense for everyone? Does anyone have
Yeah, you're muted.
Did anyone hear? No? Okay, so please visit this ngrok reverse tunnel, and it will visit this lottery website. So currently there's no winner. In order to join the lottery game, as Fran explained, you will need to create a stream to this app. And this app actually also charges a ticket fee. So the ticket fee is held by the app. And once the app receives a stream, it will draw a new winner, right? So I'm gonna do it now. Please also do it on the background when you can. So Ming that I approve, then join the lottery, okay? I don't think there's auto update, so you would need to refresh if anyone plays. But since I just played, I should be able to see the new winner. It should be me, of course, because it's only me at the moment. Did you refresh? No. Okay, let me refresh. Okay, that's me. So if anyone also joined, let's see who's the next winner. While you are clicking, I'm just go through the contract code quickly and right, I should mention that's in goerli network. Make sure you are on goerli network, testnet.
I get an exception thrown in the contract code. Transfer amount exceeds allowance.
Oh, did you do approve?
I did approve, but it didn't pop up. Okay. I think it didn't draw the MetaMask pop-up. Let's try.
Okay, so I'll just go back on in the background, explain a little bit. So the lottery app is a contract that basically it receives the callbacks. Think of it as 777, but for the stream, ERC 777, but for the stream. So each time there is a new stream created against the app will do a redraw. And each time there is a stream deleted, the game also redraw. Okay, somebody has trouble to actually use it. Okay.
Does it say I joined or not?
Okay, so let's see who's the new winner. I need to refresh because we just hacked it up today, so it's not very polished yet. Let's see who's the new winner. Somebody else, not me. So I'm actually sending a lot of flow now to somebody else. So the app will keep accumulating incoming flows and there'll be only one winner. But in order to play it, you have to pay one DAI as ticket fee, right? So you can just keep playing if you really want, but it will redraw each time you play it. But that's the funny incentive. But the point is, it's not really a well thought out game, but the point is that it showcases how the money streaming game could be built with a framework. With a usage of the callbacks and also with the usage of something called a batch call, because under the hood, there's a lot of magic happening. I'm just going to show you quickly what's the batch call so that you can get a feel of it. If I go to the demo app, what the hell is it? UI source app JS batch call. Remember that we are playing with a super DAI, right? The super DAI needs to be transferred to the app as a ticket fee. But normally with ERC20, you would have to do approve and then let the app to withdraw your money. But with our framework, we have a batch call feature. So you basically batch everything into one. So I'm going to read through. So first, you upgrade 100 DAI X to play the game. All right, so this one will first upgrade. It's currently uses a very hard to read number, but that 2 means operation upgrade. 0 means approve, so you are approving the app to withdraw 1 DAI X, 1 super DAI, to pay the ticket. Then you call the app contract participate, which will withdraw 1 super DAI from you. And in the end, you create a flow against the app address with a minimum game flow. So if you create a flow that's less than this, the app will reject your play and revert everything. You could send more because the app is not really thought out, but this is minimum you should send. And once this is transaction through, which is essentially what happens when you do the join lottery, and then the game will be triggered a joining process, and a new winner will be triggered, right? So who is the lucky 7C51? Is that fun? No, somebody else? All right.
It's me, yeah.
Cool. So we can keep playing this game. You just keep paying one die and a new winner will join. So it's the more people plays, the more the winner would gain, right? So that's the game incentive. So it's all available. Time is running out, but it's all available already in the preview, and have a look at the sample integrations. The super app demo I'm showing you here is here. Actually, we have a really cool UI will be published, I think, very soon, but the one you see here is a bit rudimentary we created, but we polished a little bit just in time also. So after the call, we'll be able to publish it. But have a look of these, and if you have any questions, I don't know how much time we have left.
1 minute.
Okay, no problem, right. I think we will have more follow-up session also. Hopefully it shows you the gist of what Superfluid is. We're still actively working on it. We're gonna release more agreements, and I would believe that the app design space would be a lot. And we're also releasing the user dashboard and all the commercial side of things fairly soon. So stay in touch. Follow us on Twitter, come to our Discord chat, and more importantly, ETH Online. Hackathon is now, so I hope this app showing you a good example that how you can play around with it, and please please use our framework to build some cool stuff, and we are here to help in the Discord. Just want to say something?
Yeah, just wanted to mention, guys, so you see here it's mint some die and approve die, right? So those are the first two actions that a user has to do, and we can't really get away with with removing those, as I'm sure you all know, because of how the ERC20 contract works, right? But what happens after that is kind of one of the magic things that Superfluid does. So the join lottery, it's all built in JavaScript, right? This batch call is all built in JavaScript. So you can basically batch any number of calls for the user without deploying a contract. And this is just not possible within ERC20. And basically, I think it's pretty cool. Like normally, as Meow showed you, it's like 4 operations. So normally that would be either 4 operations or probably deploying a contract that does those 4 operations. But here, you know, depending on what the status of the user is, you could generate this batched operation in a different way. So in general, it kind of gives you a very nice way to build a UX where users only need to approve once, right? They only need to call 1 transaction. So it's also how we get around meta transactions. So the batch call basically requires 1 meta transaction, and then it executes all the calls after that. So by doing it this way, you can basically save a lot on gas. So I hope that made sense for everyone.
Cool. Yeah, thank you so much, Fran and Meow. And I actually have to leave, so I can't extend anymore. But like we recorded this video session, so I'm going to upload the video into YouTube channel. So hopefully you guys can revise, and if there's any questions, I think you can continue in your Superfluid Discord channel. Okay, thank you very much, guys, and don't forget to withdraw your commitment.
Thanks, guys.
Thank you.
Thanks, everyone.
Thank you.
Thank you.
Cheers.
Bye.
Bye, everybody.
Thank you. Bye.
Thank you so much. Bye-bye.
Thanks.